Okay, so the video recording has started. Finding the number one is inverse Laplace of these two expressions. So we see that there is a 9 here, right? That's like 3 squared. So we need a 3 in the numerator. So we can rewrite this as 5/3 times the inverse Laplace of 3 over s squared plus 3 squared. So that we get 5/3. And that's in the form, if you look in the tables, it's like sine of 3t. They did upload the tables on Blackboard. Make sure you know where everything is so you don't waste time trying to find where the conversions are for problems. So get familiar with that. All right. Any questions on this? So this one is pretty simple. You just divide by 3 to get 3 in the numerator. And then you have the sine of 3t formula. For this one, what is the first step? We separate it. So we have 2 Laplaces. So I can say 2 inverse Laplace of s divided by s squared plus 4 squared plus 5 times the inverse Laplace of 1 over s squared plus 4 squared. What do I need to divide by here in this problem? Divide by 4. So we multiply a 4 in the numerator to make that into a form. So this is equal to 2. With the s in the numerator on the left part, we have cosine of 4t plus 5/4. So the second part, we have sine of just t. Should be sine of 4t. So any questions on this one? The trick was to separate it, and then you just look at the table. So now we have equation, and we find the Laplace of it. Y double prime minus 6y prime plus 2y equal to t, d to the t. Initial conditions, y of 0 is equal to 2. Y prime of 0 is equal to 1. So they just want us to find the Laplace transform, not the inverse, so we can leave it as y of s. So we do the Laplace of the entire thing. Laplace of y double prime is s squared times y of s minus s times y of 0 minus y prime of y of 0. Any questions on that? You guys should be really familiar with that. Minus 6 times the quantity of s, y of s, minus y of 0, plus 2 times y of s. And this is equal to the Laplace of t e to t. And I think there's probably a table for that. Table down. Let me open a table really quickly. Yeah, the formula for that is when we have t to the n, e to the nt, something like that. So, e to the st. The Laplace transform of that my bad. When it's t to the n, e to the at, the Laplace transform of that is n factorial divided by s minus a to the n plus 1 power. So that you would get from the table. So in this case, n is equal to a 1, a is equal to a 1. So our Laplace transform is 1 over s minus 1 quantity squared. So it's good to be familiar where everything is in the table to do that quickly. And if you watch the video, the sound quality will always be bad unless I get a separate microphone or something, which I might see if Reach has one for me. But then the point is, once you have done that, is just to isolate y of s. So y of s is equal is multiplied by, first we have s squared, then minus 6s plus 2. Y of 0 goes to 2. Y prime of 0 goes to 1. So this goes to 2 here. So that on the left-hand side, I have minus 2s minus 1 plus 12. This is again equal to 1 over s minus 1 quantity squared. So that's y of s in the end is equal to 1 over s squared minus 6s plus 2. That quantity being multiplied by 2s minus 11 plus 1 over s minus 1 quantity squared. So then you bring that portion to the right-hand side. Any questions on this problem? You guys are all good with the problem? Yes? Can I erase it? Yeah. So for 3, we have the inverse Laplace of 2 over s plus 3 times the quantity of s minus 1. So s plus 3 and s minus 1 denominator. The first part asks us to use partial fractions. So we know that that is equal to inverse Laplace of a over s plus 3 plus b over s minus 1. What method is the best way? Heavy side. So a is equal to limit as s approaches -3, because that will make this part equal to 0. We multiply s minus 3 to everything, so that this is equal to 2 over s minus 1. We plug in a -3 here, so we get 2 over -4, so -1/2 for a. For b, we multiply everything by s minus 1, so we get limit as s approaches a +1 So we get 2 over s plus 3. So that's 2 over 4, positive 1/2. 1/2 times, so this would be, the s plus 3 is the denominator, so that gives us negative e to the minus 3t plus s minus 1 is the denominator plus e to the t. That makes sense? I just took out 1/2, but this would still be a negative e to the minus 3t, and this is a positive e to the t. Any questions on that portion? Yes?
Why didn't you multiply to get how many numerator? Multiply a by s minus 1 multiply b.
Yeah, so that would be using the common coefficient method, or something like that, the name is whatever. Then you solve for, then you get an equation in the top which will be equal to 2. The Heaviside method, in my opinion, is quicker in this case, so that's why we use it here, but you can do both. And the new method really that you learned this time is convolutions. So the next part is doing convolutions. So I have the inverse Laplace. We need to separate this into 2 portions, so I can do 2 over s plus 3 times 1 over s minus 1. So that gives me, the first part is f of s, the second part is g of s. Okay? If that was f of s, and we had to find f of t, what would f of t be? It'd be 2 times e to the minus 3t, and g of t would be what? E to the t. So what you guys learned from convolutions is that the inverse Laplace of f of s times g of s is equal to the convolution of f with g, which is equal to, from 0 to t, of f of t minus v times g of v, g of v. So that's the formula we'll use. So that our integral from 0 to t is equal to 2 times e to the minus 3 times t minus v quantity multiplied by e to the v, d of v. This is equal to e to the minus 3t times e to the positive 3v, and then v multiplied by e to the v. And we treat t like a coefficient, so we get 2 e to the minus 3t out of the integral. So it's an integral from 0 to t of e to the 4v dv. And tell me to slow down if I'm going too fast. So this is equal to 2 e to the minus 3t of 1/4 times e to the 4v going from 0 to t. So this I split, and then I added the v portions together. Did this make sense? So now we plug in t into 0, so this is equal to 1/2 e to the minus 3t times the quantity of e plug in t to the v, so it's 4 to the t, minus e to the 0, which is 1. And when you multiply this across, we get 1/2 e to the minus 3t times e to the 4th t is just e to the t. So that minus e to the negative 3t. And this is the same answer as partial fraction decomposition. Any questions on this? All right, the next one is a longer problem. We have to solve for y of t from y double prime minus 6y prime plus 5y equal to the step function of u of t minus 1. But the initial conditions are both equal to 0. Okay? So that simplifies a lot if they're both equal to 0. So taking the Laplace of both sides, I realized that this old exam doesn't cover impulses, so make sure you know that. Okay? But going back to this problem, Laplace of it, I have s squared times y of s. That's all I really need to write since I know the rest portions are going to be zeros because of the initial conditions. So s squared y of s minus 6 s times y of s plus 5 y of s. Did that make sense? Yeah? I didn't need to write anything else for each portion because I knew they'd be 0. The Laplace of the step function will be e to the minus s over s, and just the minus s because it's t minus 1. Okay? Then we isolate y of s, and then I'll just do this step in one, or this process in one. We bring the other stuff to the other side, so I will end up with e to the minus s over s times the quantity of 1 over s squared minus 6 s plus 5. So I isolated y of s. So we have to solve for y of t, so we use partial fraction decomposition. So this is equal to, so I have a s here. How can we factor this denominator out? I have s minus 5 times s minus 1. So that my 3 fractions for partial fraction decomposition are a over s plus b over s minus 5 plus c over s minus 1. So what would the best method be to use? Heaviside. So A is equal to limit 0. We multiply everything by s so that we are left with 1 over s minus 5 times s minus 1, which is equal to 1 over negative 5 times the negative 1. So this is 1/5. B is limit as s approaches a positive 5. To make that portion 0, we multiply by everything by s minus 5, so we are left with limit of the expression being 1 over s times s minus 1, which is equal to 1 over 5 times 4. So that's 1 over 20. And for C, limit as s approaches a positive 1 of 1 over s times s minus 5, which is equal to 1 over s times a negative 4, or 1 over 1 times a negative 4. So it's negative 1/4. So that y of s is equal to 1/5 times e to the minus s over s plus 1 over 20 times e to the minus s divided by s minus 5 minus 1/4 e to the minus s divided by s minus 1. Okay. Y of t. This is where we need to realize that e to the minus s means it's a step function. So I have 1/5. The inverse Laplace of that is just 1. The inverse Laplace of 1 over s would be 1. So then e to the minus s, I multiply by u of t minus 1. Okay. For the next part, I have plus 1 over 20. The inverse Laplace of 1 over s minus 5 is e to the 5, but then we need to do t minus 1, because that's the step, and we multiply it by u of t minus 1. If there was no step, it'd be e to the 5t, but we need to do t minus 1. Minus 1/4. Inverse Laplace of 1 over s minus 1 is e to the t, but it would be t minus 1 in this case, times u of t minus 1. Yeah.
Can you explain the total step function first? So
Okay.
recognize.
So we need to recognize that so this is being multiplied by e to the minus s, right? That means there's a step function involved. So this 1 here means that the step was just 1, is equal to 1. So we need to multiply the end result by u of t minus 1, regardless of anything else. Okay? Since this is just 1 over s, inverse Laplace of that is just 1, so that's it for that portion. On this portion, though, we have 1 minus 1 divided by s minus 5 as our expression, right? So 1 over s minus 5, Laplace, inverse Laplace of that is e to the 5t. Wherever there's a t, we need to do t minus 1. And then we add on u of t minus 1. Did that make sense? Yeah? This stuff doesn't go away, so make sure you understand it and ask as many questions. Are you guys good to move on to the next one? Yes? Okay. 5, we have f of t is equal to the quantity, and then I guess the expression. 3 is between 0 and 1. 3 is between 0 and 1. Negative 5 is between 1 and 3. 0 is between 3 and 4. And t is between 4 and infinity. So we need to represent this first as a unit step function. So each of these essentially turn on and off at their respective ranges. So the first one essentially its magnitude is 3, and it turns on at 0. So I have u of t. And it's turned on until we reach 1, right? So then we do a minus 3 of u of t minus 1. So that's when it stops. The magnitude of negative 5, so it's technically plus, because we're turning it on, negative 5 at time equals 1. So we do u of t minus 1. And it goes on until we reach 3. So we do a subtraction of negative 5, because that's when it stops, of u of t minus 3. Do you guys understand, like, plus, and then it's a negative 5 magnitude? Minus is when it stops, but it's a negative 5 magnitude at 3. With 0, you can essentially ignore that, because we already turned the function off at 3, so there's nothing going on. And the magnitude is 0, so it would turn out to be 0 anyway when we multiplied it. But for t, we turn the function t on when time is equal to 4, so step of t minus 4. And it remains on, so we don't ever subtract anything. It goes on till infinity. Any questions on how that worked? And you can simplify this. So with just u of t, that's the only part there. So the simplification would just be start off with u times u of t. There's 2 portions though with t minus 1. Okay, so we can add those. So it's the minus 3 minus 5, so minus 8 u of t minus 1. So if you were to graph this, you'd have a difference of 3 between the first and the second. At t minus 3, I just have 1 plus 5 u of t minus 3. and then plus t of u of t minus 4. Taking the Laplace of the function, with this, e to the negative s would just go to 1 because it's a minus 0, right? So then the Laplace of u of t is not really relevant. Laplace of 3 is 3 over s. Minus 8 with u of t minus 1. I have a minus 8 essentially over s times e to the minus s because a is equal to a 1. So the next portion is plus 5 over s times e to the minus 3s plus. Now this is where it might get a bit confusing. We don't just have a magnitude here, we have a t. Okay? When you have a function there, you need to translate it, the point, like the time. So this we could think of it as t minus 4 plus 4. Okay? In order to move this to a t minus 4 location. Okay? So I'm going to try to really go through this picture. This can be separated out as t minus 4 of t minus 4 plus 4 of u of t minus 4. Now this, like, you can go through the derivation and understand it, but I'm sort of just going to tell you. This is, even though we have a t minus 4, it is still the function t, okay? And when you do the inverse Laplace of it, no, when you do the Laplace of it, you already have the step function and the transition taken care of with the u of t minus 4. So when you take the Laplace of this portion, you only take the Laplace of t. So I have 1 over s squared. That's the Laplace of t. And then we multiply that by e to the minus 4s to take care of the step portion. Okay? But by doing this, we also get the plus 4, though, which we would have forgotten if it was just a t of u of t minus 4. So then this plus 4 gives us 4 over s times e to the minus 4s. Does that make sense? Somewhat? Yeah? We want the function t to be at the same place as u of t minus 4. So we separate it by doing t minus 4 and then plus 4, keeping it equal. So it becomes two expressions, t minus 4 times u of t minus 4 plus 4 times u of t minus 4. The t minus 4, we just take the Laplace of t, and the step portion is e to the minus 4s. But that gives us plus 4, so then we do the Laplace of that. Now, let me erase this one. If you don't want to think through all of that, and you're told you have t of u of t minus 4, what you can just do is make it plus t plus 4 of u of t minus 4. Essentially the opposite sign of whatever is right there. And then do the Laplace of each. So then I would have e to the minus 4s from the step part times the quantity of 1 over s squared plus 4 over s. So if you don't want to think about what actually went on, and you just see that instead of just a number, you actually have a function here of t, you just add opposite of what is here. Okay? So then it'd be t plus 4, and then you do the separate Laplaces and multiply by the step Laplace. Did that make sense? But now we're still, what if you have t squared? And this is part of the video where they went over a problem like this. Say we have t squared u of t minus 4. Okay? Then what you need to do is not as simple as doing this. Then we need to do t minus 4 plus 4 quantity squared u of t minus 4. So this is to make sure nothing really changed. We group the t minus 4 as one portion, so that in the end we have t minus 4 quantity squared u of t minus 4 plus 2 times t minus 4 times 4 u of t minus 4 plus 16 u of t minus 4. So then I essentially treated this like a squared plus b squared. Sorry, a plus b quantity squared. So that we get a squared plus 2ab plus b squared. Did that part make somewhat sense? Yeah. This 2 right here. So it'd be essentially, this a plus b quantity squared is a squared plus 2ab plus b squared. Because if there were 2 of them, a plus b, it'd be, we'd have a times b and b times a, so that plus 2 times ab. So that's where, in the case, you do need to understand what happens instead of just doing t plus 4. And the rest of that problem, you just group them together. I'll write out the answer here, but do you guys all understand what went on here? If I had t squared and how to separate that out? So when you do the inverse Laplace, you still treat this as t squared. You don't do the inverse Laplace of t minus 4, okay? You treat this as t squared. You would treat this as 8t, and then this would be 16 times u of t minus 4. We just need to make sure that they are at the right place with 4 seconds. Any questions on that? Do you want me to say that again? No? Okay, we're going to move on. And I'll write out the final answer right here. So the final answer comes out to be 3 minus 8 e to the minus s plus 5 e to the minus 3s, and all of those are under s, plus e to the minus 4s times the quantity of 1 over s squared plus 4 over s. So that's the answer. You guys get to move on to the window problem. So we have a sine of 2t function. One thing to always that you have to figure out is what is the period of the problem. So what portion does it go before repeating? Okay. So what's the period of this problem? 2 pi. Even though there's nothing here, this entire portion is what we'll repeat on. Okay? So then we have to write f of t of the period. So the function is sine of 2t. It's turned on at u of t. So we do minus. It's turned off at pi. It's not turned off at 2 pi, but that function is turned off at u of t minus pi. So that's the equation, but it goes on till 2 pi as 0. Part B is taking the Laplace. So in the S domain, so it's the Laplace of each portion. Sine of 2t. Now, since it's being multiplied by u of t minus pi, we need to multiply this by e to the minus pi s, and then still have the Laplace of sine of 2 t plus pi, and that is you have to use a formula essentially. So it's moved by pi distance, I guess, when it's turned off, and then you have to multiply by e to the minus pi. Yeah, so that's the reason we add pluses in the formula. So this is equal to 2 over s squared plus 2 squared minus e to the minus pi s. The thing about so this is 2t plus 2 pi, right? What is that pi? What's the 2 pi going to do? Nothing, because it's the complete rotation of the sine function, right? So we can actually, just in this case, if it was just pi, it would be different. But since it's 2 pi, we can ignore that portion and just do e to the minus pi s times the Laplace of sine of 2t to get 2 over s squared plus 4. So this simplifies out to 2 over s squared plus 4 times the quantity of 1 minus e to the minus pi s. Does that make sense? It was plus 2 pi, and that's a complete rotation or revolution, so it doesn't matter. But that's the function of the period. The complete f of s is a formula f t of s divided by 1 minus e to the minus s t. Okay? So we can't forget this division part here. So this is equal to 2 over s squared plus 4 times the quantity of 1 minus e to the minus pi s. That entire portion divided by 1 minus e to the minus 2 pi s. The minus 2 pi was our period. Okay? And you can just end it there. They accept that as the answer. So this part is really simple. You just put it over 1 minus e to the minus s t, which is your period. Any questions on this problem? You can have a window of different functions too. Like you could have a t there afterwards that goes till 2 pi, and then it repeats or something. The process is still the same. Good to move on to 7? Yeah.
What would you do if it wasn't 2 pi?
So if you had a pi there, then you would need to use that formula for sine, where it's sine of a plus b equal to sine cosine or whatever that is. Yeah. So just know that as well. I highly doubt they'll have that. They could easily have that. The inverse Laplace of e to the minus 3s divided by s minus 3 plus 6e to the minus 5s divided by s plus 2 quantity squared plus 9. Let's make all of the s's lowercase. So we have to do the inverse Laplace of that. We can separate it out. So this is just one. This is the second one. If I had just 1 over s minus 3, so that the f of t then would be what? E to the 3t. if I had this, I can rewrite it as 2 times the quantity of 3 times e to the minus 3s, or minus 5s, divided by s plus 2 quantity squared plus 3 squared. Right? Then the first one is a 1, so this is the second function. Then if I were to if I ignored the transfer function portion, this would be equal to e to the minus 2t sine of 3t. Do you guys all see what I'm doing? I'm just trying to see the Laplace of the main function, ignoring the transfer portion. So the first part, it would be e to the 3t, e to the minus 2t sine of 3t, and everything multiplied by a 2. So that when I actually do the find f of t, now I can take in portion the transfer function. So then I have e to the 3, and the first one I have a is equal to a 3, so I have e to the 3 times the quantity of t minus 3. So I have, and then multiplied by u of t minus 3. Okay? Plus 2 times e to the minus 2. So this t here, I need to do t minus 5, because that's my a value, times sine of 3, and then t minus 5. Make sure you show that the minus 5 is just applied to the t. Quantity times u of t minus 5. So the way I did that one is I first figured out if there was no transfer portion, and then just subbed in wherever there was a t. Any questions on this one? You guys good? Okay, so last one. So now I have to find the Laplace of t squared. So there's a t squared being applied to sine of 3t. I think this was like 3a in the unit. My n value is a 2. So this means I have a negative 1 to the squared power, and I'm doing a second derivative of the Laplace of sine of 3t. Okay? So not the second derivative of sine of 3t, but the Laplace of that. The Laplace of sine of 3t is equal to 3 over s squared plus 9. Okay? So let's just do those derivatives. So the first time I have low, s squared plus 9, derivative of the top, s squared plus 9 times 0, minus high, so minus 3, d low, derivative of the bottom, which is 2s, divided by denominator squared, s squared plus 9, quantity squared. So that's the first derivative of it. Now I need to do the second derivative of it. So this portion is 0 on the top. So this is minus 6s at the top. So the second portion, I have low s squared plus 9 quantity squared. Derivative of the top will be just minus 6 minus high, so it's minus the negative 6s times derivative of the denominator. So for that, we'd actually use the chain rule. So it's 2 times s squared plus 9 times 2s. Do you guys all remember that? All the way back to California. Times denominator squared, so I have s squared plus 9 to the 4th power. Okay. So we can actually simplify this.
Is that multiplied by another 2s?
Yeah, because that's the derivative of the inside. So we can actually take out this s squared plus 9, make this a cube. That would mean this top portion becomes to the 1st power. So we divided everything by s squared plus 9. So this will be equal to a negative 6 s squared minus 54 plus 6 times 2 times 2 plus 24 s squared divided by s squared plus 9 quantity cubed. And if we simplify the top, I have a positive 18 s squared minus 54 divided by s squared plus 9 quantity cubed. And don't forget that this negative 1 was squared, so it remains positive. Any questions on this problem? It was essentially taking the derivative of the Laplace. All right. Did everyone sign in? If you haven't, come up. Thanks for coming.